Now, over the next two videos, we're going to be looking at three different rules. So the chain rule, the product rule, and the quotient rule. So this video will just be on the chain rule. So to find the derivative of a composite function, we use the chain rule, which is why I asked you to practice some composite function questions at the end of last lesson. Now the chain rule is if we have y equals a function at u, and that u equals a function at x, then dy dx, the derivative, equals the derivative of y with respect to u times by the derivative of u with respect to x. Now, right now that seems a bit confusing, but once we do examples, you'll see how it works. So first example, differentiate each function. So this one here, we've got y equals x squared minus 4x all to the power of 3. First step when doing these is we're going to rewrite it as two separate functions. We're going to split our composite function back up into two separate ones. So the first function I want you to do is the inside one. And then we're going to call this u. So u will equal x squared minus 4x, so the inside part. Then we're going to do another function which is going to be y equals, and that's going to be the outside part, which is u cubed. So the next step is to do the derivative of each of these. So the first one, the derivative of this will be du on dx, which will be the derivative of x squared, which is 2x, minus the derivative of 4x, which is minus 4. And then the derivative of the y, so it'll be the derivative of dy du equals 3u squared. Now to apply our chain rule, we just multiply those two derivatives together. So dy dx will equal 2x minus 4 multiplied by 3u squared. And then we need to simplify it, and we actually sub u back in. So we're going to have 2x minus 4 multiplied by 3u, which is x squared minus 4x all squared, and then just make it look prettier, so I'll put the 3 out the front. Okay, and that's your process for your chain rule. So you define the derivative of the inside, the derivative of the outside function, and then multiply those together. Okay, b. Let's have a look at b. So b, the first thing I'm going to do here is rewrite this without the square root, which would be 5x squared minus 2 all to the power of a half. Now, u is the inside part, so the bit in the brackets, which would be 5x squared minus 2, and y is the outside bit. So we know that 5x squared minus 2 is u, so that will be u to the power of a half. And then we want to find the derivative of each of these. So derivative of u will be 5 times 2, which is 10, and x. And then derivative of minus 2 is 0. And then this side, u to the power of a half, derivative of that will be half u to the power of negative a half. Now we apply the chain rule where we multiply the two derivatives together. So dy on dx will equal 10x times by a half u to the power of negative a half. Then we want to put u back in and simplify. So we're going to have, because this is all multiplied, we're going to have 10 times a half, which is 5. Still got an x there. Then we want to put u back in, which would be 5x squared minus 2, and that's the power of negative and half. Then if you want to get rid of the negative half, you could change to 5x all over the square root of 5x squared minus 2, but that step isn't necessary. All right, let's look at c. So c, we've got y equals over the square root of 1 minus 3x. So once again, like the last question, we're going to make this look a bit nicer, which will be 2 brackets, and then we're going to have 1 minus 3x. Now the square root on the bottom of a fraction gives us to the power of a negative a half. Now this is what we're going to do the chain rule with. So our u is always the inside part of the bracket, so 1 minus 3x. our y will be the outside. So now we've got a 2 in front of the bracket, so we have to include that. So it's going to be 2 times by u to the power of negative a half. Then do the derivatives of each of these. So the derivative of u will be, derivative of 1 is 0. Derivative of minus 3x will be minus 3. Now for this one, the derivative of y, we're going to have negative a half times by the 2, which will be negative 1, u to the power of negative a half minus 1, which is minus 3 on 2. Now our final full derivative, multiply those together, so dy dx will equal negative 3 times by negative 1 u to the negative 3 on 2. And then we just simplify. So negative 3 times negative 1 will just be positive 3. Put u back in, which is 1 minus 3x, and a power negative 3 on 2. And d, same idea again. So this time we don't need to do any rearranging to start with because we've got positive powers. So we're just going to work out u is the inside part, so 5x cubed plus 2. Y is the outside, so it's 4 times by u to the power of 6. Derivative of each of these, so the derivative of u will be 5 times 3, which is 15x, and then 3 minus 2, which is 2. Then 3 minus 1, which is 2. Derivative of plus 2 is 0, and then y dash will equal 4 times 6, which is 24, u to the power of 6 minus 1, which is 5. Now we multiply the derivatives together and simplify to get our final answer. So we'll have 15x squared multiplied by 24u to the power of 5. Simplify this, so we're going to get 15 times 24, which is 360. We've got the x squared, and then we're going to put the u back in, which is 5x cubed plus 2 all to the power of 5. And that is how the chain rule works. So it's just a process, and just be really strict and methodical with this. As soon as you start to try and skip steps, that's where you're going to make a mistake. And in your booklets, you can now go to booklet 3 and complete pages 1 to 3, which is all chain rule practice.